Hello everybody, today we are going to talk about the read function. And as you can guess, it is what? It is reading from the file. But what is different from the functions that we learned about in the last lesson? Well, this function is reading whatever it is placed there, and it is not omitting, skipping anything. It is not going to end reading when it meets something. It's just reading the thing like it is. So it is especially a function that is created to read a binary files. And there is only one function like that. I mean, there is no overloaded function of that function. So we can only send here as a first argument where to read, where we want to save the thing that we read, and how many bytes we want to read from the file. Okay, at the beginning we'll just try to train this function, but after it we'll write the program which will compare content of two files. We'll know if two files are different, and in addition to this we can also check if files are different, not only text files but also image files and other things, other files like that. Well, other binary files. So all other files. Okay, so let's try, for example, read everything from the file and let's send it to the output. So how to do it? By using the read function. Well, firstly, when we use the read, so when we do it like that, we need a place to save the things that we read. So we should create a buffer, a place where we can store it. So something like that. And well, we will dynamically allocate it this time. So new character, and now we would like to know how many characters we want to create here. Well, let's not to forget also we need to delete that, because otherwise we might have a leak from our program. Let's train again something what is called at the end flag, because when we open it at the end of the flag, right now we can exactly say how big is the file, and we can create buffer which will be as big as the file, so we could read it at once totally. So file of size, and now we can just type something like file, tell where is the get indicator. And we can now create it. The buffer here, we can send the buffer here, and now we need to read only full file. And then we can send it the content to the output. Now as you can see, of course, the type of that variable is integer. We have got some kind of problems. And why is it so? Well, it's a good question, because, well, we are at the end of the file and we are still trying to read something. Exactly, we are trying to read 50 characters. It's good that I made that mistake by mistake, because right now we can see that we can repair it pretty easy just by setting the pointer of the reading at the beginning of file. As you can see, now we read everything properly, but at the end we have a small problem. And why this problem happened? Look, right now we open the file as a binary file, but we created it as a text file, and because of it, it created problems. So if we want to read this binary file, we should have inserted the names inside with the binary thing firstly. So, well, we can do it first. So, for example, we can do something like pretty fast. Let's open it for outputting also. So we'll just create a new file, which will be binary file. And let's send to the input something like that. And something like that. Now, as you can see, we have got it saved as a binary file. Now we can open this as a binary file also, and it should work. As you can see, now it's working fine. Well, should open it again. Let's edit it here. So we have got only this here. And as you can see now, everything is working fine. Because, looks like maybe in the last lessons, or well, I just inserted things inside using the text mode. And because of it, there was some problems with it. Because there are some additional characters that were read here with the read. Because read is reading everything. Doesn't matter what is there, it's reading everything. Okay, as you can see now, everything works fine. And now let's practice the read function by comparing content of two files. So how to do something like that? Well, let's delete this thing because we will not need it anymore. And now let's try to check if the files are equal. How to check it? Well, if, and let's create a function, are files equal, and we'll send here two files. We should also create two files here, so let's do it that way. File 1, file 2, sample 1, sample 2. Let's copy it with the shortcut and let's name it sample 2. So you have got now two files which are equal. And now when the file 1 is open and in the same time file 2 is open, then do things that are here. We can check if everything is working fine. So let's run the program. As you can see, files are open, so we can work with them. And now, if our files equal, so we should create a prototype of the function which will return boolean. When files are equal, we'll take here two files, and so file streams. So we take two file streams here, but file stream doesn't have a copy constructor, so we have to take here it as a pointer. We'll take pointer to that file, so we'll open it here and we'll send exact copy, well, with exact instance of the object here, right? So we send the file here but from this place here. So we send address of file 1 and address of file 2. So if our files equal, then do something. And now we should implement this function here. This is not the prototype, so we have to name that files. Well, we can name it A and B. So now we have got here a pointer, so we can use pretty easy functions by using this kind of operator. And so we can check if files are equal. I guess it's the best way to check if two files are the same, if they are equal, is to check if they are the same size firstly. Because, you know, when they are the same size, it means that, well, when they are not the same size, it means they are not equal, and we will not need to check byte by byte each character and lose our precious time, well, our precious time, the computer time. So it's pretty easier to do it that way. But of course, if if the two files are equal, so for example, like now, and somebody changed something like that, one character only, then we should check byte by one byte to check exactly if something is not well, if something is not equal there. Okay, so first let's check the size. I guess we should create a function which would check size of the file, and of course we'll also take here the fstream file stream, and here when somebody send a file, we'll take it and we will set the seek with the seek get function at the end, a pointer indicator of the reading, and because it's set there, we can now read the size of file and we can store it, for example, in temporary variable, and take it with the tell get function. And now we need to remember, it's very important to back to the beginning of file, because otherwise we might have problems later, where here we might have problems because we'll use that file. And remember that we are sending the address here, so we are operating on files that are here or that are here when we send them here. So we need to exactly be at the same place where it was when we send it, right? Well, maybe we should even check where is the file at the where is the tell get when we send a file here. But well, it would be complicated. We need to write a lot of code, which is not needed in that simple program, because there are probably thousands of things that we won't predict anyway. This is just a training program, okay? So let's just set it like that, and now return the size of file. So size of file return. Okay, so we return it here, and now we can use it here. So int file size 1 equals, and we can send there A, and file size 2, and we can send there B. Okay, now you might be, why I'm not sending their address? The file is a pointer, so it should take an address. Okay, but A is also a pointer, and it is pointing to address. So the value of that variable is an address, and the value of that variable is here. So we are sending really here an address. It's identical here. Here we have to send an address of file 1. Why? Because when we are sending here an address, well, we are expecting here an address. Okay, so we have got here now file size 1 equals size of file B, so we have two file size, and we can just check if file size 1 equals file size 2, then we can easily do something. Else we can send to the output cout files are not equal. Size of files, maybe something like size of files are not equal, and we can return false. So we can send if our files equals, we can send if files are equal. Otherwise we won't say anything because we've sent messages here or something like that. So now when we run this program, as you can see, we have got the message files are equal because, well, it's returning true by default. Files are equal. And now when we change something, so only one letter, as you can see, files are also equal, so we have to repair it. We have to fix it when files are equal. We have to check byte by byte. But when we, for example, add here a single letter, as you can see, size of files are not equal. So it means that files are just different, right? So we can send here, maybe we can do it also. Cout files are not equal. Not the same. Oh, something like that. Okay, so now let's check it byte by byte. So it's the hardest part of this program, but well, it's not that hard when we know function like read, and we know something like a function which is called memory compare. So it stands for memory compare, and as you can guess, it is comparing memory that is indicated by some kind of pointer, for example. Okay, so we need this function. We also need to include the string library, and now let's use it. Let's firstly create a place where we will save for example, when we have a file1, so when we have a file and we read something, we need to read it to some kind of place too, so we can later compare these two values. So when we do something like that, a and b read, we need two places to store it temporarily for comparing. So firstly, let's, I guess, do something like that. Character file1 buffer equals new character, and now we should use the size of the file here, or size of that file, because they are equal. So maybe let's just create here a temporary variable which will state the file size. So file size 1. And now when we run this program, we need to, of course, do it that way. File1, file2 buffer. Well, and of course we need to what? We need to delete it that way, because we don't want to have a leak from our program. So we need to do it that way. And now we should say how many bytes you want to read. So buffer size. So now we have a content of the file1 and content on the file2 in the buffers, and we can compare them. We can compare them with the function that I mentioned earlier, which is memory compare, which is comparing whatever data is inside, and we are using now memory compare. And I am sending here file1 buffer and file2 buffer. And we also have to say how many bytes we want to compare from both of the buffers. So we are sending here a buffer size, and it is very important. Memory compare is only false when it's not equal to 0. So when it's greater than 0 or lower than 0. Well, when it's greater than 0, then file1 buffer has some problems. When it's lower, then file2 buffer has problems. So memory compare is working like that, and because of that we have to do it the other way. We have to create a condition like that. And now, well, we can send that files are not equal. And we can also return false. Remember that when we return false here, we won't be able to delete here our dynamically allocated memory, so we have to delete it again here. Well, again, for the program, it is the first time in this lines of code, because if that condition is met, well, these lines won't be run at all. And vice versa, this these lines at 1661 won't be executed if the condition of this condition is not met. So let's run the program, and as you can see, files are equal. Why they are equal? Because they're equal. Well, now let's change one character, so like that, and let's run the program. As you can see, files are not equal, files are not the same. One of the byte was different, something like that. Okay, so let's go to the time when everything was equal, and now let's imagine that this thing was an image. Well, this program would work, but now image that it would be, for example, a movie, which would be, for example, 3 gigabytes or maybe even more. Wow, then this buffer size would be big. Well, as a temporary variable to take 3 gigabytes of memory, well, some people maybe don't have even that much, then it would be a bad idea, right? So we should check the buffer size. If it's not too, if it's, well, big file size, we should create it a bit different way. So if file size is bigger than, for example, 1024 bytes, so it's bigger than 1 megabyte, then please, let's do it that way. Let's create a declaration like that, and now let's initialize it here with the not file size, but only 1024. Otherwise, buffer size should be equal to file size, because, well, when the file size is lower than 1024 bytes, why should we take 1024 bytes? We can take on, for example, like right now it's only 49 bytes, so we don't need to take 1 megabyte. And now let's run our program, and as you can see, it's working, but the problem is our files are right now very small. Let's for a second do it that way, the way that we will initialize it with only 10. It means that buffer size is now lower. So it means that we will read only 10 bytes of file 1 and 10 bytes of file 2, and we can compare only 10 bytes of both files. So if that first 10 bytes will be equal, the file would be equal, but we need to read all file at once. So we need to repeat all the things as long as we do not read the file. So how to repeat things? When you hear the word repeat, we need to remember to repeat it with the loops, because loops are created for repeating things. So we are creating do while loop, which is going to execute as long as the file 1 will have a good state, and at the same time file 2 will have, which is big this time, because we are sending it as a B, will have also a good state. So we're gonna repeat this as long as it's needed. Okay, so now when we run these programs, files are equal, and when we change something, so for example here, as you can see, files are not equal. One of the byte was different, so something was wrong. I should say at least one of the byte was different. Okay, so let's go back to the buffer size, which would be create a bit more professional, because 10 bytes is not much for a file, and we would need to repeat this thing too many times if the file was big. So maybe even 1 megabyte is not big. Maybe we should create it 10 megabytes, 20 megabytes. It depends on the situation, how important this task is and how fast we want it to be. Okay, that's all in the lesson. Thank you very much.